The synthesis of benzyl alcohol and benzoic acid. Attention! In this video, caustic, toxic and highly flammable compounds are used. Especially when working with diethyl ether, all precautions have to be taken. I don't take any responsibility for damage done to persons or property caused by the replication of this experiment. First, 27 grams of potassium hydroxide were dissolved in 18 milliliters of distilled water. When the solution had heated up to its maximum, it was stirred. Then the beaker was covered and put aside until the solution had cooled down again. When the solution had cooled down, 30 grams of freshly distilled benzaldehyde were added to a 250 milliliter round bottom flask. Then the potassium hydroxide solution was added. The flask was closed with a stopper and a clamp and shaken until an emulsion had formed that did not separate again. The following reaction takes place. One half of the benzaldehyde is reduced to form the alcohol, which causes the other half to be oxidized to the carbonic acid, so this is a disproportionation. When an aldehyde has no hydrogen atom in the alpha position, this reaction takes place and is called Cannizzaro reaction. The mechanism consists of two paths. In the first one, the aldehyde group is attacked by an hydroxide ion which acts as a nucleophile, leading to a diol of which one OH group is deprotonated. This is then deprotonated by another hydroxide ion, which causes a dianion to form. The hydrogen atom of the dianion acts as a nucleophilic hydride ion and attacks another aldehyde group. This leads to a deprotonated carboxyl group and an alkoxide. The alkoxide is then protonated by the water and benzyl alcohol and benzoic acid are formed. On the second path, the diol, which has one deprotonated OH group, reacts differently. Here the attack of the nucleophilic hydride ion happens already in this step, leading to a protonated carboxyl group and an alkoxide. The alkoxide is protonated by the carboxyl group, leading to the formation of benzoic acid and benzyl alcohol. When the emulsion became a little thicker, the clamp was removed, the flask was clamped to the ring stand and the stopper was loosened. The mixture then begins to heat up and can become very hot, which causes the air in the flask to expand. In this case, the flask became so hot that it could barely be touched for a while. When the flask was only slightly warmer than body temperature, the clamp was added again and the mixture was left to sit overnight. On the next day, the mixture should have lost the smell of benzaldehyde, which was not the case, so it was left to sit for another day. On the next day, this didn't change, so the next step was done. This should have only a slight effect on the yield. Next, a bit of distilled water was added and the flask was shaken vigorously. The goal is to dissolve the mixture in as less water as possible. In the end, a cloudy solution was obtained. The cloudiness might be due to the benzyl alcohol being only moderately soluble in water. The solution was then added to a separating funnel. The flask was washed out with some distilled water. Next, the solution was washed 5 times with 30 milliliters of diethyl ether. It's important to vent a few times, otherwise the pressure that builds up might get too high. The benzyl alcohol is highly soluble in the ether, while potassium benzoate stays in the aqueous layer. MTB ether or dichloromethane could be used instead, where the latter would cause the lower layer to be the organic layer. The stopper was loosened and the layers were left to separate. The lower aqueous layer was separated, where it is better to have a slight amount of the ether in the aqueous layer than the other way around. Extracting several times causes the benzyl alcohol to be removed completely, while the high concentration of potassium benzoate in the aqueous layer stays constant. The organic layers were collected in another separatory funnel. The aqueous layer was then washed with ether again. Here are the both solutions, where the organic solution contains the benzyl alcohol and the aqueous solution potassium benzoate. Both were somewhat cloudy because they contain traces of the other layer, which is not a problem. First, the organic solution will be worked up. For this, 6.7 grams of sodium metabisulfite were mixed with 10 milliliters of distilled water, but a few more milliliters had to be added until the metabisulfite had dissolved completely. Then half of the solution was added to the organic solution. It was shaken for 5 minutes and repeated with the other half of the metabisulfite solution. When sodium metabisulfite is dissolved in water, it is hydrolyzed, forming sodium bisulfite. This can react with aldehydes and ketones in a bisulfite addition reaction to form a water-soluble compound and remove benzaldehyde. After that, it was washed with 10 milliliters of a diluted sodium bicarbonate solution and 20 milliliters of distilled water. The bicarbonate removes traces of benzoic acid and the water removes residual salts. Then the solution was added to an Erlenmeyer flask and dried with anhydrous sodium sulfate. A good amount of anhydrous sodium sulfate is added and the flask is swirled, leading to the solution to become clear very quickly. When the sodium sulfate is flowing freely, the solution is dry, but it is left to sit for a few minutes. Next, the sulfate is usually filtered off, but it was decided to simply pour off the solution. This prevents larger amounts of diethyl ether from evaporating. Then it was set up for simple distillation. A water bath was used for heating, but an oil bath could also be used at this point already. The receiving flask was cooled with ice water due to the highly volatile ether. After a short while, the ether began to boil. The temperature on the thermometer was at 35 degrees, which is at the boiling point of diethyl ether. The goal is to remove as much of the ether as possible, because otherwise too much of it would evaporate in the next step. When the volume in the distilling flask became very small, the solution was transferred to a smaller flask. The flask was washed out with a bit of ether. Then the distillation was continued. When the distillation became slow, the temperature of the water bath was increased. At the end, the temperature of the water bath was at 90 degrees C and the distillation became very slow. So the distillation was stopped and the receiving flask was swapped to an empty one. The water bath was changed to an oil bath. To the vacuum stopper, a diaphragm pump was connected. An oil pump could be used instead, but then a cold trap has to be added between the apparatus and the pump. At first it is not heated but stirred vigorously, and then the pump is turned on. The condenser is already running. Residual ether evaporates immediately, which can become dangerous with larger amounts of ether. Only after adding the vacuum, the apparatus can be heated. After a short while I noticed that the thermometer adapter couldn't keep the thermometer in place, so it was slowly sucked into the apparatus. Luckily nothing did break and the apparatus was not heated up very much at this point. The apparatus was vented carefully, the thermometer adapter was removed and a glass stopper was added instead. After a while, the product in the distilling flask began to boil, but nothing was distilled, so the apparatus was isolated. Then the product could reach the condenser. Benzyl alcohol has its boiling point at 205 degrees C, which is why it has to be distilled in a vacuum. Vegetable oil begins to smoke slightly at this point, and the distilling bridge could break at the cooler due to the temperature difference. The temperature of the oil bath was at 114 degrees C, which meant that the benzyl alcohol has to boil below this point, so the vacuum of the pump was strong enough to lower the boiling point by around 100 degrees C. Due to the somewhat low temperature, the distillation was left to run until it died down by itself. Usually a distillation is not left to run until dryness. The residue in the flask indicated that the vacuum distillation was useful. Nevertheless, 2 drops collected in the product within the distillation which later dissolved again. Next, the refractive index was determined. This was close to the literature value of benzyl alcohol. The deviation might be due to the impurity, but the refractive index of benzyl alcohol with a purity of at least 99% is said to be at 1.390. So the impurity can be neglected when using it in a further synthesis. 12.1 grams of benzyl alcohol were obtained, which corresponds to a yield of 79%. To improve the yield, I would recommend to use a microdistilling bridge. Next, the aqueous solution was worked up. The flask was washed out with some distilled water. Then the solution was acidified with half-concentrated hydrochloric acid while stirring. This causes the benzoic acid to be protonated while potassium chloride is formed. The protonated benzoic acid is sparingly soluble in cold water. The goal is to get the solution to a pH of 2 or 1. A large amount of acid had to be added, which was the reason why a larger beaker had to be used at some point, so it would be better to use a large beaker from the beginning. At the end, some concentrated hydrochloric acid was added to reach the desired pH. Then the mixture was put in the fridge overnight so all of the benzoic acid could crystallize. It was then removed from the solution with a vacuum filtration. Residues were washed out of the beaker with distilled water. It was left on the pump for a while to dry it, but this is not necessary. The benzoic acid was then transferred into a 500 ml round bottom flask for recrystallization. A simple reflux apparatus was set up with an oil bath and a Dimroth condenser. A small amount of solvent was added through the condenser as it is usually done in a recrystallization. When the solvent is boiling, another small portion of the solvent is added and it is left to heat up until it boils again. The goal is to get a boiling saturated solution. Unfortunately, it was not considered that about 250 milliliters of boiling water were needed to dissolve this amount of benzoic acid. So at least 200 milliliters of distilled water could be added from the beginning to save some time. Interestingly, the undissolved benzoic acid was present in droplets instead of crystals. When everything had dissolved, the flask was removed from the oil bath. Within 10 minutes, needle-shaped crystals were formed. The flask was left in the fridge overnight and the crystals were filtered off. It was then washed out with some distilled water again. Then the crystals were sucked dry again for several minutes. After that, they still contain a lot of water, so they have to be dried in air or in a desiccator. As a desiccant, concentrated sulfuric acid was added to the bottom. It was not put under vacuum because benzoic acid is able to sublime. At the end, 15.2 grams of benzoic acid were obtained, which corresponds to a yield of 88%. The melting point of benzoic acid is at 122 degrees C, but the product was only at 117 degrees C. The commercial product had the same low melting point, so there might be traces of water that are not removed as easy. This was the synthesis of benzyl alcohol and benzoic acid. I hope you enjoyed. Please rate and comment. If you want to see more synthesis, you can watch my playlist here, or you can watch my latest video here. A big thanks to my supporters on Patreon.